it's going to get copied over to our container. And so under volumes in our API, we're going to define a volume here. And I'll say volumes, right? Just like we did with Postgres, very similar, except we're going to use a different syntax because this is a bind mount. So a bind mount, we have to first provide the path of the folder that we want to sync on our local machine. So this is our current directory. So we can just do // for current directory. But if you wanted to sync just one individual folder, maybe like the app folder, then you can do /app, up to you, but I'm going to sync everything. And then we have to specify the path in our Docker container, which is going to be this folder right here. And that's going to automatically sync the two folders. And if you wanted to add some extra security, you can do RO. This means read only. So what this does is this makes it so your container can't change any of these files, because only we should be changing the files, not the container itself. So this just adds a little bit of extra security if you wanted to, but it's still technically optional. And let me exit out of here. And now we'll do a docker-compose down. And we'll do a Docker compose up again. And now let's just change this all together. So bind mount works. So if we see that, that means everything's working. So let's save it. And if I send, we can see that I get the old one now, right? So whatever I changed here doesn't get copied over. So it looks like we didn't fix the issue. So let's actually take a look and see what's happening. And so how do we do that? We'll do the docker exec command again to go into the file system. Let's go into the app folder and let's cat that main.py file. And this is interesting because it looks like the bind mount did work because we can see that the code got updated. And if I make another change again, this time let's just add sort of. And if I cat this again, we can see that it's in there. So the bind mount is working and it's syncing the code with our local directory and our container, but there's one issue. And if I go back to my Docker file, you can see that I have my command right here, but this doesn't have the -- reload flag, which is what we need to restart the application. So anytime we make changes to our code, we need it to automatically reload when it detects any changes so that we can actually see the new application. And we didn't provide that in the Docker file, and so that's why it's not working. So this is actually a pretty simple fix. We just add the -- reload flag. So let's tear everything down. And we have a couple of options. So I can go here and say -- reload, and that would work just fine. But instead of doing that, what I would rather do is, I like this default one because this is the one you would technically use in production because you don't want -- reload in production. But in our Docker compose file, we can actually overwrite it. So we can provide another flag called command. And here we can provide a command to overwrite that from the Docker file. So I'll say uvcorn app.main app -- host 000 -- port 8000 -- reload. All right, and let's bring this back up. Let's just see what it is currently right now. So we got whatever it is now, and let's make a quick change. And I'll just delete all of this and change this back to hello world. And let's test this out. And we can see that it does successfully update. And so now our bind mount works and we automatically restart our code. So our development environment more closely matches up with what we had before we moved to Docker. Okay, so if you haven't already done so, go ahead and create an account on Docker Hub. It's a free account, but I want to show you guys how we can set up a repository on Docker Hub so that we can actually store our images here. And so Docker Hub is kind of like the Docker equivalent of GitHub, where it's kind of acting as a repository, but instead of a repository for our code, it's a repository for our images. So we can upload our images. Anytime we make a new image, we can actually upload it so that we can track changes to our images over time. So make an account, and then we want to go into repositories. and we want to select create repository, and then give this a name. It doesn't really matter what you want to call it. I'm just going to call it Fast API. And then we're going to do public because you only get one private repository. And so now we have a private well, it's the public repository. And so this is the URL to the repository, which is going to be your username. This is my username. And then this is the name that I gave it, so Fast API. And so now what I want to do is I have an image, right? If I do docker image ls, we could see that I have my Fast API underscore API. This is going to be the image that I want. And so how do I actually upload this image to Docker Hub? Well, there's a command called docker push. All right, so if I do a docker push -- help, you just pass in docker push and then the name of the image. So let's try doing that. We'll do docker push and then the name of the image, which remember, yours is going to be a little bit different because it's going to be based off of your folder. Let's try this. And it says requested access to resource is denied. So the first thing that we have to do is we actually have to do a Docker login. So we have to log into our account. So you do Docker login here. It's going to ask for your credentials. So we'll do sloppy networks in this case for me, and then it's going to be whatever it is for you guys. And then now let's try to push it again. And once again, we get a access to resource is denied. So what exactly is happening here? Well, when we want to push up a image, right, there's a very specific naming convention that we have to use, right? We have to name it exactly like this, sloppy networks / Fast API. And we even see an example right here. So you do docker push, the name of your email or your account name, then the name of the specific repository, and then you can give it an optional tag name. So what we got to do is we got to rename our image. So how do we do that? I think it's docker image. I think, well, let's do -- help just to see if we can figure it out. We want tag. So this essentially copies an image and renames it for you. So let's do docker image tag -- help. And here we just provide the source image and then the target image. So what is my image called again? It's going to be this one right here. And we just do docker image tag, then the image that we want to rename. And then we give it the new name, which has to be your account / then the repository. And then you have an optional, tag. The default is just going to be latest. So I'm just going to leave it without a tag. So I do that. And if I do a docker image ls, we should see the new one right here. And so now I can do a docker push. It looks like I didn't copy that. So let's try this one more time. And now it looks like it's pushing something. So let's give this a minute or two. And then once it's done, let's take a look to see if we have successfully pushed it to our repository. All right, so it looks like it's successfully pushed. So now if I go back to my Docker Hub page and do a refresh, we can see that last pushed was a few seconds ago. So now we've successfully pushed it to our Docker Hub. And so, if we set up an actual production Docker environment, we could just pull the image from this specific URL or this specific repository. Now, before we wrap up the Docker section of this course, there's one last thing that I want to show you guys. And that is that if you take a look at what we have right now, we have a identical clone of our previous development environment, but we're now developing within a Docker container. So our Docker container environment is a exact clone of our previous development environment. The issue is that, when we move to production, assuming that you're using Docker in production, which is kind of the main idea behind Docker, is that your development environment and your production environment are almost exactly the same because you're using the same exact Docker images and containers. But if we try to use this Docker compose file in production, there's going to be a whole bunch of issues. First of all, obviously these environment variables would need to change and we can't hard code them. We wouldn't want the -- reload flag. And you certainly don't want a bind mount because the code shouldn't be changing. And then the ports that we use could also potentially be different. So even though the Docker environments from our production and development environment should be roughly similar, there are going to be some differences. And so we need to account for that. And so what I like to do is I actually like to create two different Docker Compose files, one for development and one for production. So that's what we're going to do. But first of all, let's do a Docker Compose dash down so that we can just tear everything down for a second. And once that's down, I'm going to copy this and paste it. And we're going to rename these files. So this one is going to be called Docker Compose -dev. So this is going to represent our development environment. And this one is going to represent our prod environment. All right, so we've got our dev and our prod environment. The dev doesn't need to change because we had already set that up for a development environment. The production one is going to change a little bit. So first of all, the command, right? We don't want the -- reload. So we could specify the exact command we want, which is the one without the -- reload. And that should be all that we need. However, keep in mind, this is the default command from the Docker file, right? So we could technically just remove this or just comment it out. And so I'm just going to comment it out in this case. But if you wanted a specific custom command for production, you can just provide that here. The whole idea is that this file is going to represent all the changes for our production environment. Then maybe we want, instead of listening on port 8000, we want port 80 so that we can use our web browser. Most of the things can stay the same. The environment variables definitely need to change. And so with a production environment, first of all, we're not going to hard code the values. We usually want to grab these values from the environment variable set on the host machine. So instead of actually hard coding these in, instead we can reference environment variables. So to reference an environment variable, what we do is we do $ curly braces and then the name of the environment variable. So it's going to look on the Linux machine that it's running on for a environment variable called database hostname. So I figured we would just have them match just to show you what that would look like. And then we're going to do the same for all of these. And I'm just going to copy and paste this once again. So it's going to look like this. So it's just grabbing the data, the environment variable from the local machine. Keep in mind, they don't technically need to match, but it just makes it easier for troubleshooting purposes. And then for the Postgres database, right, we would want the password to be the same environment variable. And then we would want the database name so that we're not hard coding that one as well. And we don't want the bind mount, so we will remove that. And that's about it. So that's all you have to do. So this just gives us both a development environment and a production environment. We'll save all of that. Now, starting up Docker Compose is going to be a little bit different now because we don't use the default docker-compose.yaml file name. So if I do a Docker Compose, if I can find the up, docker-compose up, right, you're going to see that it throws an error, right? Because it says it can't find a docker-compose.yaml or .yaml with an A or compose.yaml or compose.yaml with an A. So it looks for only these file names. So when we have a custom file name, we have to do docker-compose. And then we pass in the -f flag for the file name. And so we provide the path to the file. So it's just in the current directory. So I could just do docker-compose-dev.yaml. And then we just do an up and then -d. And then we can start it back up. And if you want to bring up a production environment, then you would do --prod. That's the only difference. So you don't really have to do anything else other than running the different specific Docker Compose file. And the last thing that I want to change is actually in your production environment, you don't actually ever want to build the image in a production environment. Instead, what's recommended is that when you're done developing, you push the brand new image to Docker Hub, right? And then in the production environment, we just pull this image from Docker Hub. So how do we pull this image from Docker Hub? Easy. We remove this build option. Remember, this is going to be in the prod file. And we set this to be a image. And here we just set this to the name of the repository. So we just do, your username /fast API not dash app, just fast API. So whatever is essentially right here. And then if you want a specific image with a specific tag, then you would add the tag as well. And so that's all we have to do. Feel free to stop your containers now if you want. And even when you do a down, you want to make sure you do a -F. So it knows which file to actually look for. And I misspelled that. And that's going to conclude the Docker section of this course. And so I think this is going to give you a solid foundation on how to Dockerize your Fast API. Now, currently, whenever we make changes to our code, whether it's implementing a new feature or modifying the behavior of a previous feature or even fixing some bugs that we happen to catch, right, we have no idea if the changes we make break other functionality in our code. And so normally anytime we make any changes, we then have to go into Postman and essentially manually test out every single scenario to ensure that things are working. And this isn't a very scalable solution. It's going to result in a lot of wasted hours. For every single time you make any changes to your code, you're going to have to test everything because you don't know what code you've broken by making those changes. And so this is where an automated testing library comes into play, where we can define a whole bunch of tests to test a majority of the functionality of our code. And so that way, anytime we make changes to our code, we can run our tests to see if we've broken anything. And keep in mind, obviously we can't test for everything, but we can at least test for enough things that we can catch some of the more obvious bugs. And so this section of the course is going to be dedicated to getting started with testing and really understanding the concepts of testing and seeing how we can get started with a library like PyTest. But I do want to provide one little disclaimer before moving forward. I wasn't originally going to post a section on testing for this course. And the reason for that is that I don't have much experience with testing. It's not something I do a lot of or at all, really. And so I want to make sure that you guys understand where I'm coming from when it comes to testing. And that is that, since I am not super proficient at testing, I don't really feel too qualified to actually teach it. And so what I want you guys to do take out of this section of the course is just how to get started with testing. How do you set things up? And what's the main ideas behind a test? I may not necessarily be teaching the best, most efficient way to test. I may not be using the most efficient way of testing. And there may be scenarios where I may not even be following best practices, but I want to show you guys how we can at least get some integration tests set up. And then at that point, what you guys can do is you can just forget everything else that I've taught you when it comes to testing. Once you at least have the groundwork, then you guys can, do your own research, figure out how you ultimately want to implement testing with any of your projects, and then go ahead and just run with that. So with that in mind, in the next video, we'll get started with getting PyTest installed and writing our first test. For testing, the library that we're going to be using is PyTest. So if you do a quick Google search, you can just search for PyTest, and the first result is going to take you to the documentation page for the PyTest library. And so I recommend you guys take a quick look at this just to see how it gets set up. And if you go on and do a little bit of reading before we actually get started writing our first test, definitely go ahead and do that. But once we've got that opened up, what we can do is we can install PyTest. So we can just do pip install PyTest just like we would with any other package. Then once that's done, we have access to the PyTest command. So just go ahead and run PyTest and see what happens. So it prints out a few things. You notice that we can see that the test session starts. So this is when we start testing. It prints out some information about the platform that we're running on, and that's okay. We can ignore all of that. And you'll notice that it says collected 0 items. We'll talk about this in a bit, but the more important thing to look at is it says no test ran in 0.04 seconds. And this is expected. We haven't created any tests, so obviously it's not going to be able to run any tests. But to run our testing, all we have to do is just run this command, and then you'll see that PyTest will go through all of your tests, run it to verify that they all pass, and if there's any errors or anything like that, it's going to report that. So it really is as simple as that. But let's go ahead and create our test. And I want to store all of our tests inside a directory called tests. So inside the root directory of your project, just create a new folder. We'll call it tests. And technically, you can put this folder anywhere. If you wanted to put this test directory within your app directory, you absolutely could. It's a matter of personal preference. I'm just going to keep it outside of the app directory for now. And within here, I'm going to actually create a file. And this is going to store our first test. I'm just going to call this mytest.py for now. All right. And we obviously need to test a part of our code, whether that's a route or a path operation or a function or a class. We need to test something. And right now our code is a little advanced. And when I say advanced, I don't mean advanced because anything we've done is super advanced so far. It's advanced from the perspective of testing, where we're coming in from a background of no knowledge of testing. So we want to start out with testing the simplest functions. So I'm going to actually create a brand new module and essentially create the simplest module or function that I can possibly think of. So I'm going to create a new file, call it whatever you want. I'm going to call this calculations because it's essentially going to be a bunch of functions that we use to perform certain calculations. And I'm going to define the world's simplest function, which is called add. And I think you can guess what this function is going to do. It's going to take two numbers, which is going to be type int, and it's just going to return the sum of them. So we just say return num1 plus num2. Right? And the reason, once again, is because this is going to be very simple when it comes to testing, so you guys can at least have an understanding of how to actually perform these tests. So we've got this module defined inside our app directory. And then in our tests folder, we've got our mytest.py. And we're going to define our first test. So what is a test? Well, it's really just a function. It's either a function or a method within a class. We're going to start off with just doing functions because it's just a lot easier. And we're going to call this function test_add. Why did I give it that name? Well, it's testing the add function, so I think that makes sense. And technically the naming does matter, but we'll come back to that in a bit. Now, how does this function actually work from a testing perspective? Well, it's very simple. PyTest will run through all of our tests. And when it runs through this specific test, what it's going to do is if it runs through it and there's no errors get thrown, that means the test has passed. It's succeeded. That means our code is good. If our function throws an error of any kind, it's going to consider our function or our test as failing. Then the test has failed. So how exactly does that work? It's simple. We use something called assert. And if you aren't familiar with what the assert command does in Python, anytime you assert a true value, nothing's going to happen. The code just runs. However, if you assert a false value, that means it's going to throw an error. So it's no different than raising an error or throwing an error. In Python, it's just a simple way of doing that for testing purposes. If we return something that's true, then the assert won't do anything. If we return something that's false, then it will raise a Python error. And I'm going to show you exactly how that works. So if I just say assert true, and before this, I'm just going to do a print testing add function. And then down here, I'm going to just call the test_add function right here. And I'm going to just run this as a normal Python module. So we're not going to even treat it as an actual test or anything like that. We're not even going to use PyTest. So I'm just going to call Python. And keep in mind, the command is Python on Mac, but it's Py-3 on Windows. And then we're going to go into the test directory. And we're going to call my test.py, and I'm going to show you what happens. All right, we can see it says testing add function, which is from this print statement. And then you can see the assert did nothing. So it just ran and everything's fine. And that's expected because, like I said, assert only does something when we return a false value. So if I say false now, and I run this code, take a look at what happens. Hey, look, Python throws an error. So assert is simple as that. True means nothing's going to happen. False means it's going to throw an error. And we don't have to just say true or false. We can actually pass in a condition. So if I say 1 = 1, that's going to return true, right? So technically, an assert of true won't do anything. However, if I say 1 = 2, that's going to be a false statement. And if I run that, we can see that it asserts and it throws an error. So that's how we make use of assert within our testing functions. So I'm going to remove this. And we're actually going to test out our code now. So to test out our add function, the first thing that we have to do is we actually have to import it into this file. So we're going to import it. So we'll say from, and we have to go into the app directory and the calculations module. So we'll say app.calculations, import add. And now what we're going to do is we're just going to call the add function like we normally do. And we need to give it some test data. So I want you to think of two numbers that you want to use for testing, add them up, and what is the result should it be? So I'm going to say, I'm going to do 5 and 3. And I know that this function, if it works properly, should return a value of 8 because 5 plus 3 equals 8. And so I can just take the sum, store that in a variable called sum. And what we can do is, since I know sum should ultimately be equal to 8, I can assert that. And there should be no either. So I can say sum equals 8. So that means if our code runs fine, sum should ultimately equal 8. And if we assert 8 equals 8, that means it's going to return true and nothing should happen. Or PyTest should consider it as passing. However, if I mess up my code and for some reason the add function returns a value of 20, then when we do assert 20 equals 8, well, that's going to be false. And it's going to throw an error, and it's going to consider that as a failing test because an error means a failed test. So that is the main idea behind a simple automated test within PyTest, right? You run the code with some test data, and you know what the result should be because you created this test data, and you just make sure that the result of the code matches with your expected result. So let's actually run our test now. So I'm going to do PyTest, and let's see what happens. And you see the same exact thing we saw before. Once again, it says it collected 0 items, no tests ran. And so why exactly is this happening? Well, if we go to our documentation and you scroll down to this feature section, you go to the auto discovery section. And so this auto discovery section is going to explain how PyTest finds all of the tests in your code. Because it does have a auto discovery functionality where it can actually go through all of your code, all of the directories and packages, and recursively look through them and find the tests. But it looks for specific keywords. And you can see in these directories, it looks for any files that start with test. So you have to do test underscore and then some name, or some name underscore test.py. And if we go to our code, right, we name this my test. This does not match what it's going to look for. And that's why it doesn't actually find any tests from that. So let's change this. I'm going to call this, let me rename this, and I'm going to call this, how about test underscore calculations. All right, and so now if I run this, you can see that it throws an error, but I realized that, within my tests package, I do need to have the usual underscore init underscore .py to actually make it a package. So I'm going to do the same thing. I'll do underscore init underscore .py. Because of that, it wasn't able to actually import the file properly. So let's save that and let's try this again. So now if I run this, you can see that, hey, look, we collected 1 item. So I think it's safe to say that this collected 1 item probably means we have 1 test. So the number of tests equals items. And then we can see that inside the tests package, we have a module called test underscore calculations.py. And then there's a little dot. So the dot represents 1 individual test. And a green dot means good. A red dot means it failed, right? Green is pass, red is fail. And so if you have 2 tests, then you would see 2 dots. And then if the second test passed, it would be green. If it failed, it would be red. Simple as that. And so now we have successfully ran our first test. And just to make our code a little bit simpler, right, I could just, instead of having the sum variable, I can just cut this out, just paste it into here just to make it a little bit cleaner, and then we can remove all of this. And just to make sure I didn't break anything, let's run our test again. And we can see that once again, it worked just fine. Now, when it comes to the auto discovery of files, a few things to note. You don't necessarily have to follow this convention of test underscore calculations. If I actually rename this, and I call this, my underscore test, what did I call this? My test.py. Right now, if I obviously run this, it's not going to find any tests, but I can pass in the specific path or the specific module that I want to test. So if I do my test.py, then it is able to find the test. But I like to have PyTest be able to automatically find all my tests so that I don't have to specify this. So we'll rename this and go back to test underscore calculations, because it ultimately is a module that's going to be testing my calculations module. And another thing to note, the name of the test within the module also matters. If I call this, maybe something like testing underscore add, take a look at what happens. Whoops. I wanted to auto find it now. and I forgot to save it. Now, if I run this, it looks like it still works, but let me change this to just something random. Right? And so now we can see that no tests ran. So the naming of the function absolutely matters when it comes to auto-discovering tests, and you want to stick to the standard of test underscore something. And I think somewhere in this documentation, it's going to go over, here we go, test from those files, collect test items. So a test prefixed test function or method outside of a class, or a test prefix test function or method inside a test prefix test clause. So it's got to start with test, essentially. It doesn't necessarily have to be test underscore. That's why testing underscore add worked just fine. It does have to start with the word test. That's why if I said add underscore test, I don't think this will work actually. Shouldn't based off of their description, and it doesn't. So keep in mind that the naming does matter. And I recommend you stick to the convention of naming all of your testing modules test underscore, then the name of the module that you want to test, and then your functions test underscore, and then the name of the function that you want to test or the functionality that you want to test. Now, a couple